Hello, Year 10. This is Mr. Radmull, and this is the second lesson in the triple physics topic, Particles and Radiation 2. Okay, let's get started. So the driving question today is, how do you calculate changes in gas pressure? We're going to put some numbers in. So first up, just a reminder, which A or B, start a question, which shows the highest gas pressure? A or B? Okay, it's B, if you remember, because with the same number of particles, there'll be a higher frequency of collisions because there's less surface area. So B shows a higher pressure with a lower volume. Right, so let's just acquaint ourselves with volume and pressure. So pressure is a measure of how spread out or concentrated a force is. So a good example to think about is if you're wearing high heels, then that force is really concentrated and that would make a very high pressure. So, stand on someone's foot, it's going to hurt. However, wear snowshoes, your force is spread out. That's very low pressure and you're not going to sink into any snow, which would be, which is quite advantageous when you're in a place with a lot of snow. The units of pressure. The unit is the Newton per meter squared. You might also come across that as called the Pascal or PA. So two possible units for pressure, newtons per meter squared and the Pascal. So volume is a measure of how much space an object or substance takes up. The unit of volume is the meter cubed. You might you also, of course, use on the course volume of liquid, milliliters, liters, etc. But we're going to use the standard unit of volume, meters cubed. So very quickly, those keywords and key ideas. Which statement is the porcupine, which is East London slang for lie? Pause the video and spot the porcupine, please. Okay, if the volume of a gas decreases, the gas pressure will actually increase from last lesson. Okay, so let's put some numbers in. So here is a gas in a piston that's being compressed. It starts off at 100 newtons, a pressure of 100 newtons per meter squared, volume 6 meters cubed. And then the pressure goes up to 200 newtons per meter squared and the volume goes down to 3 meters cubed. Let's have a think about what these numbers tell us. So as we go from one to the other, we see that we've halved the volume. We've gone from 6 meters cubed to 3 meters cubed. And the pressure has doubled. It's gone from 100 to 200. Now, this relationship between gas pressure and volume has a special name, and it's a mathematical relationship which comes up a lot in physics, and we're going to talk about it in a minute. So going the other way, so we increase the volume, we see the volume doubles, the pressure halves. So if you double one thing, the other thing halves. This relationship is called inversely proportional. Pressure, gas pressure, is inversely proportional to volume. As the pressure increases, the volume decreases. Or as the volume increases, the pressure decreases. If you double the pressure, you halve the volume. If you double the volume, you halve the pressure. Pressure is inversely proportional to volume. Just a couple of more examples of this, of quantities which are inversely proportional to each other. So if you get further away from a radiation source, like a light source, a light bulb, then the greater the distance, the less the brightness, showing a type of inverse proportionality. Builders and time taken to build a wall is another example of inverse proportionality. The more builders you have building a wall, the less time it will take. So back to our volume and gas pressure, which is what we're focusing on. So the pressure and volume of a gas, if we multiply them together, we get a constant. Okay, we get a number. If we then compress the gas, we squeeze it to make it smaller to get a second volume and a second pressure, we find that that second pressure and second volume multiplied together gives us the same constant because they're inversely proportional. Okay, let's go back to our numbers here, see if that works out for us. So there's our gas on the left-hand side. 100 times 6 is 600. Then we squeeze the gas, and we see that our new pressure and volume multiplied together gives us the same number, the same constant. This gives us a new equation involving gas pressure and volume. The pressure and volume of a gas multiplied together is equal to its new pressure and volume multiplied together. And this is assuming that we haven't made the gas hotter, we haven't changed the temperature, and we've got the same mass of gas, the same number of particles. So P1 V1 equals P2 V2. So what does this mean? It means that if we know the pressure and volume of a gas, and then we squeeze the gas to a new volume which we know, we can work out what that pressure is. If we know three things, we can work out the fourth thing. So again, let's bring together some of these ideas. Which statement is the porky pie? Pause the video, see if you can spot it, year 10. Okay, did you get it? Okay, it was C. So if you double the volume, the pressure will double. That's not correct, year 10. If you halve the volume of a gas, if you make it twice as small, then the pressure will then double. Okay. Right, some numbers. So just have a look at the numbers here without any complicated calculations. See if you can spot what the final pressure of the gas will be. Okay, pause the video. Okay, so in this example here, we see we're halving the volume. So because volume is indirectly proportional to pressure, if we've halved the volume, we must double the pressure. That gives us a pressure of 10 newtons per meter squared because we've gone from 5 to 10. Okay, so just to run through an example of if the numbers are not straightforward, doubling, tripling, quadrupling, putting the numbers into the gas pressure equation. Okay, so let's say we have a gas with volume 40 meters cubed and pressure 1000 newtons per meter squared. I beg your pardon, 1000 newtons per meter squared. And then we compress it to just a bit smaller, 35 meters cubed. What would the new pressure be? So first up, write down the gas pressure volume equation. Then put the numbers in that we know. 1000 times 40 equals P2 times 35. Then simplify it. We've got 1000 times 40, so let's just make that 40,000. And we've still got numbers on both sides, so we want to get that 35 onto the other side of the equal side, leaving the unknown on the other side, the second pressure. So we can put 35 on the other side. If it's times 35 on one side, it's divided by 35 on the other side. So that gives us 40,000 divided by 35 equals the second pressure. And lo and behold, now put that into our calculator. we find our new pressure is going to be 1,143 newtons per meter squared. Okay, so time to give it a go. Can you pause the video and work your way through the questions, please? Pause the video. Okay, let's go through some answers. So the units for pressure and volume, newtons per meter squared, meters cubed. Okay, the gas constant is simply going to be the volume times the pressure. That's 0.15 newtons per meter squared. Right, calculating new pressure. You should have got 2.5 newtons per meter squared. And new volume, you should have got 0.2 meters squared. What have, sorry, year 10, that should be 0.2 meters cubed. What have you assumed in these calculations? The temperature doesn't change and the mass doesn't change. Okay, so next up, how do we show that these numbers are indirectly proportional? Well, we multiply them together, and each time you multiply them together, you should get the same number. That's how we prove that pressure and volume are inversely proportional. Multiply the numbers together, you should get the same number each time. Okay, so it should be inversely proportional. And then the PV graph to show the relationship should look a bit like this. You should sketch, starts up high, comes down low like that. Let's put a P there, excuse the handwriting, and a V there. Okay, so a gas has a volume. So working with percentages and factors, you should have got 85.71 newtons per meter squared. And percentages, you should have got a 33% decrease in volume. Okay, so where are we today, please, year 10? Can you copy and complete the plenary statement, please? Pause the video. Okay, and don't forget there's now a show my homework quiz for you to complete, and we will be recording the quiz results. Okay, year 10, this has been Mr. Rabmore. I trust you are all safe and well, and I look forward to seeing you for lesson 3.